here that looks like there is that, let us assume that this is the path of the particle. Now at any time t, it is in the intersection here, no? So I'm going to post something somewhere here. Where is it? So inay magod ang okay, loaded na akong PC. So I'm going to put something here. Let us see that this is the particle, no? That's the particle. It travels along this path. So always there is a tangential. A tangential component is what we call this is the point, no? Initial. If you do a tangent line, so this is the tangent line, no? Along E sub t. And there's also corresponding normal component to that along E sub n. So the red arrows here, which form 90 degrees with each other, are called the tangential and normal component of the motion of the particle. Okay, that's why our topic for this morning is about tangential and normal component. Okay, of the particle which travel on this assumed path. No. Okay. Aside from x and y, no, x and y. Okay, so that's it. Now, E sub t, E with a subscript letter T, and E with a subscript in are what we call unit vectors, no? Unit vectors. This is similar to the unit vectors along X. What do you call the unit vector along X? Anybody? The unit vector along X, what is the symbol? Do you still remember your statics? Okay, so unit vector along X is I and J, no? And along Z axis is K. So, but they are for the XYZ axis. So we reserve those symbol I, J, K as the unit vectors for the axis X, Y, Z, no? So, however, for for the tangential and normal component, we will not be using IGK, but we will use E sub t and E sub n. So, that is the difference between E sub t, E sub n to I and J. Okay? So, that's it, no? So, that's the first one, yeah. The particle as it travels along the curve has always normal, tangential and normal component. Okay? So, now, you notice that E sub t, unit vectors along tangential and normal directions are E sub t and E sub n. Okay? Ako na siya himoong kuhan. Tapuuna ko na siya para maayot na naon. Sa pera ka ba ko ba? 16 siguro, no? Then kini siya, himoong ko na siya bold. Kaya basta, naka-bold gani, pasabot na niya, Victor, no? Victor. Yeah, para klaro, dili siya one word, ako na siya himoong Sanskrit. Okay. So, basically, these are just unit vectors, no? Unit vectors. So, their value has a maximum of 1. Okay? So, that's it. Now, some more, no? I'll go to one. Now, okay, what else? So, rho is the instantaneous radius of curvature, no? So, because there is what we call curve path here, every time there's a change of radius, no, at any instant, the particle negotiate a curve having a radius of curvature, but this radius of curvature changes, or else it travels in a perfect circle. It radius will not change, no. But here, we see that this is not a perfect circle. So, as the particle travels along this path, the radius will also change. Okay, so that's why it's called instantaneous radius. Okay. Now, let us consider that at any time t, the particle is here, it has a velocity, no? It has a tangential velocity, or the velocity is always along the velocity is always along the tangential direction, no? So velocity is along tangential direction, no? Tangential direction. Ano siya ang velocity? Right? It's always direction. So, knowing that, no, na ang velocity di ay always gina siya tangent sa path, no? So, in vector quantity, v, in vector quantity, v is equals to the tangential acceleration of velocity times the unit vector. Instead of using I, J, E, we use E sub T and E sub N. So, the velocity vector, the velocity vector is, lang akong paan. Is that is the velocity vector, no? So, ako inapuan yapon para uniform sila. Okay. So, E sub T here actually is the unit vector, no? In which the V sub T is acting. So, V is the tangential velocity. Tangential velocity, no? So, this is the velocity expressed in vector at any time t. Okay? From calculus, okay, acceleration is A equals to dv dt. So, it's the first derivative of velocity with respect to time. So, we know this from calculus. Okay. Is this correct? Acceleration is equals to dv dt, class? Huh?
Yes, sir. Yes, sir.
Okay. But we have already an expression of velocity here. It is a product of v and the unit vector. So therefore, if we are going to derive this expression, we can have an acceleration, right? So from there, we will derive that, and mauna siya ang mahitabo. Okay, muna na yung acceleration, no? Isa ito na yun. Okay, muna na siya ang acceleration niya. Okay. So, mauna siya. So, A equals to, this is a product, so it could be, what is the derivative of a product? You have V du plus U dv, no? So, first you have that one, then derivative of the other, plus, Oh yeah, but this one is another, no, another. So I have to explain this one, no. This is b squared equals to an, no. So only the first one is the derivative of this, but this one, but basically acceleration has, because you see that the one is curving, so there should be a force that is pulling this together, just like why our planet travel in elliptical uh, shape as it revolves around the sun, no? So it has something to do with the attraction, no? Gravitational attraction, no? So there is that. So uh, maybe you have heard centripetal and centrifugal force, no? So this one can explain. So acceleration has both tangential and normal component, no? But from calculus, it's like this, no? But in the equation, actually, there is no uh, no mention about normal component from this expression. But in the derivation of acceleration, there is already normal component en. So how come? Okay, so I think it comes from here. No, it comes from here. So where is it? So we have so yan ini siya. Okay, so there is a change of one direction, position of p or to p prime, no, because we are considering that the particle is moving. So there is a change. There's also a change in direction. Somebody is pulling the particle towards the left. No, that's why it is curving up. No, so there's also what we call change of angle here. Angular. No? In fact, if we are going to to plot et and e prime t, so it becomes like this, like that. No, so just to show the change of angle theta theta, that there is really change, no? As you go to P prime. In fact, if you do a tangent line at P prime, the what we call this, the alignment is somewhat not coincident with the tangent line drawn at P. So there is a delta theta form. Now, this arrow here from the tip of E, T, and E prime is what we call delta ET. I change sa tangential unit vector. The change of tangential unit vector. Okay? So, na siya. So we can from there, no? We'll have this. Okay. That ET is 2 sine delta T 2, no? The length of ET is 1 because as I have told you, this is unit, no? Unit vector. Unit vector naman siya, no? Unit vector. So, kung unit vector siya, ang length din sa ET o ET prime are 1. But there's a change, no? Of direction. That's why there's a delta theta here. And then the distance between the from the tip of ET prime ET to ET prime is delta ET. Now, if you are going to compute that very small distance, that is, actually, kung tungaon ni mo ni siyang delta theta, doon na kay delta theta over 2, no? So, it forms a right triangle, no? A right triangle, in which the distance is 1/2 of delta ET. That 1/2 of delta ET is sine of delta theta divided by 2. But we want the delta ET, so we multiply it by 2, no? So, that is the the explanation here if you're looking for this, no? So delta theta is divided into 2, okay? And you have there a right, if you draw a line from here to there, you have a right triangle. So that's why you have this, okay? It's just like having a right triangle actually. Okay. Now, we take the derivative of that with respect to theta. So limit delta theta equal to 0. So meaning that if delta theta is very, very small, so if you multiply, if you derive this one, this is the derivative actually, delta theta over 2. So this is what they call the normal component. No? So En is equals to derivative of Et over delta theta. Delta theta. Okay. So En is equivalent to delta Et, E sub t, and delta theta. Okay. Now, if we are going to find what is the answer of En, actually, we go to here. Here. Nabatian din yung music class? Nabati mo sa music? Okay, so with that, no? Balik ta sa figure. Okay. So P prime, it travels at delta S, and this is delta theta. If you want to determine what is that delta theta, that is equals to delta S over rho, no? This one, delta S over rho. Okay, so because the arc actually is radius times angle, no? In radian. So delta S equals to rho times delta theta, actually. So from that equation, we can formulate that delta theta is equals to delta S over rho. Okay. So we move on. Okay. So actually, if we go back here, if we go back from this equation, supposedly it's like this. If we are going to derive that, that's just equal to dv dt, but since this is a product, so you have et times dv dt plus v times det times dt. No? So it's like that. Okay. So also, okay, so from that already that that acceleration equals to dv dt et plus v equals to dv et, which is equal to dv dt et plus v times actually kini nga kuan gigamitan ni niya chain rule, no? Nagamit ni siya og chain rule. Kini siya gigamitan og chain rule, no? Okay, gigamitan na og chain rule. So instead na dA d theta, so gimultiply siya og d theta over d theta. Dato pa, nya multiply sa siya og ds over ds. So d theta over d theta, d theta over d theta is actually nothing. That's 1. And ds over ds is 1. But if you insert this d theta ds over d theta ds into this equation, a lot will cancel, no? May ma-cancel. So mahimo na siyang kuan. This process actually is what we call chain rule, no? Chain rule. So you are actually just manipulating the simple equation. You multiply it with the number one. Nothing will happen, but the form will just change. No, the form will change. Like d theta ds over d theta ds is actually equal to 1. No, that is you insert into this equation that I've circled. Okay, so what will happen actually after that? They become like this. Okay. So knowing that this one is okay. So okay, knowing that the from our previous derivation that En En is equal to this from the change of angle, no? So we know that, and we have a figure here dET. So that will become dN, and then the value rho d theta equals to ds, and ds d theta equals to b. So this one is coming from here. Okay, that rho d theta is this one. Okay, that's the ds, or if you're looking for ds and this is d theta and this is rho, the arc distance of the length of the arc is equals to this, no? So that one. Okay. So substituting all of this. Okay, if we substitute all of that, this one into that equation, we will form a new equation actually. So we have this. We have that, no? So leaving the first term dt et, wala na tabo diha, but this one, this long equation after inserting d theta ds and d theta ds, imo na siyang i-substitute diha, it will become this one, no? So which is similar to this equation. Okay? So okay, wala na siya kalainan aning equation, no? So that one. Pero kaniha mangod gilali na ko ni siya sa start. Kung moderate ko din dili matingala ta nganong naa ni siya nga term. Okay? So mao na karon nga mao din ni ang iyang derivative. Nya inilang din ang gi-manipulate actually. Gi-manipulate nato nga part, no? So that part. So gamit ta og chain rule, the book really uses chain rule here, and then substitute the fact, no, that rho d theta equals to ds and dt equals to v. Okay, so this one we already derived this from this, so we come up into an equation like this. So therefore we have this one. Okay. So simply say that the normal so we can say that okay, that the initial component of acceleration reflects change of speed and the normal component reflects change of direction. Okay. So and then also we have Okay. You have also this one. So we can say that the tangential acceleration is equals to that one, and the normal component okay. So En E EP tangential component of acceleration is EP. Okay, tangential normal component of acceleration is En. Okay, so may kuan is EP. Okay, so EP here is the normal component, which is the change of speed with respect to time, and the En is equals to velocity squared over rho. No, this is the responsible for making the object, particle, or rigid body to travel in a curved direction because of the d squared over rho. No, so aside from gravity, if you throw a ball horizontally, you notice that the ball will not travel horizontally forever, but it will fall to the ground. So meaning it travels into a curvilinear trajectory because of the action of gravity. No? So here the normal component and the tangential component is defined. No, here. So that is the one of the point of discussion this morning class, that a particle as it travels along a curvilinear path actually, okay, curvilinear path like this one. I will save this now. Sure. Then I put this into ESC 17. Save. Okay. So I'm saving this one. Okay. So as it travels actually, based on this, doon na siya itawag ng tangential and normal component, which is this one, dBdt. Instead of using I, you use ETY because it's not along X, it's along tangential direction. And b squared over rho with multiply that with that product to value to E sub n, where E sub n is a unit vector along the normal direction. So that's it. Okay, class. So mao to siya ang derivation sa normal or tangential and normal component of a body or a particle traveling a curved trajectory. No? So aside from the tangential acceleration, which is tangent to the instantaneous point, there is also that normal component that pull, no, that pull the particle to curve, no, to curve. Okay, so which is equal to b squared over rho. Okay, so I have already derived. Now, as I have mentioned a while ago, I will solve an example that will reinforce our discussion this morning. So it's about tangential and normal component. Okay. So the problem is this one. Okay. I am going to continue with that. No? I am going to continue with that. Without this, to continue with that. But okay. So what happened is I am now so that I can apply the equation. Okay. So that I can apply the equation. What will I do is I to solve example. Oh, I will say here. Okay. So we can use this equation actually is I'm going to make an example. Example 1, no? Followed by example 2. We'll have two examples today. Okay, so I will make it big. So many seconds, guys. Ayan ito. This is okay. So because so in order that we can apply this equation, this one. Yeah. We will have an example. Okay. So the example is this one. Kaluman. Okay. So okay, so tapos sa pasudlo ng bagting. Ko pa din sunod. Okay. So we have already derived this one. So now it's time for example so that we can use this one. So kung tanong mo kung saan may gamit ani atong gi-derive karon. Well, we can actually determine usage of this equation through this example. Okay, so I will paste an example. Okay, so here, in this example, let us say, nagpalupad ka og drone. Yeah. Ang drone ka ni picture sa road as in. Ang road is not always straight actually. Some of the road are curved. No? That is defined by its curvature. No? Its curvature. Okay. Ang curvature actually class, ang curvature actually, okay, ang curvature actually is a curve, no? On the road, no? Sa, like for example, habang nakita curve, dapit nga dalan, diya sa may Villanueva, no? Na-curve diya, no? As you enter San Martin, going to Poblacion, na-curve diya nga dalan, no? So if you go also to naidako kay curve diya sa Banilapit. Kanang usaka ka kuan, usaka ka og payon ka sa Mambatangan, no? From Carmen Hill. So the road there is not straight, but they are curved. But ang road man good is design na siya in such a way nga doon na gina siya specific code of curvature. And every specific code curvature, doon na gina siya speed limit. You cannot just run the same speed. Yan, lahi ang curvature. No? So, nganong udagan ka, mag-drive ka, nganong minor magkarapit sa kurbada. Hadlok ka nga malabay, no? Hadlok ka malabay. Because there is that centrifugal force. Okay? So, in fact, ang ubang dalan ng curve, dili flat ang dalan. Kung dili ang takilid, butingala ka, there is difference of elevation from the other side to the other side, no? Just to help, no? Vehicle maintain its traction, no? Kaya kung wala yung traction, malambay mo siya, no? Actually, malambay siya sa other end. Kung kusog ay ang speed. That's why some has to uh, slow down, no? So just like for example, if you watch mm, Formula One, no? Formula One. So when it's running on a straight road, running up to 250 miles per hour, no? 3 miles per hour Manila. But when there's a curve, they have to slow down, or else mabangga sila sa wall, no? Maslam sila sa wall. Now, I think you've also experienced that. Kung, sometimes nga, kung gamay kayo curvature, kanang gamay ang curvature sharp corner, no? Sharp corner. So, kung na siyang gamay ang curvature, so kung mo nang i-do, ang curve niya na, if you connect the two lines, so some of that are removing a curve, no? Kung right angle, zero ang curvature, ana. So, na ay ko, no? So ang design dito sa highway actually do na gina-shake curvature, no? So just like bulwa, no? Na curve dia dapit sa sa dapit ng curve siya. Kining gikan ka diya sa West Central School kay pas by Uber, do na siya curve, no? Na siya curve dia kay ang direction sa duha ka dalan are different, no? So do na curve dia, no? Ang curve is to facilitate smooth transition. Actually, smooth transition. Okay? Doon na sa ibang dalan nga, gamay agad kay curvature, no? Gamay kay curvature. So, kung dako og curvature, mo na dako makusog yung dalan diha, dagan diha, dako mag curvature. Nang dili nimo mo kantayan nga curve day ka, no? Pero kung ang tawag na tong sharp curve, meaning gamay iyang radius of curvature. Okay? Gamay yung radius of curvature. Okay. Doon natin mga dalan nga ma-experience ng gamay ang curvature. So para comfortable ang atong ride, dili ta medyo malabay, dili ta makuan is muhinay ta og dagan, no? So yan na ang mahitabo. So in this problem okay. I will read establishing on a curved section of highway of radius 750. So that's the radius 750 meters at the speed of 90 kilometer per hour. Remember, it's kilometer per hour, it's not meter per second. Okay. The motorist suddenly applies the brakes, causing the automobile to slow down at a constant rate. So, muna ako giingon sa una nga, ganiha nga, if you enter into a curved road, you have to slow down, no? Okay? So, slow down siya, no? Now, kung hindi ka slow down, actually, may tabo is, you have an uncomfortable ride, pwede ka kasi tawag ka ng mabali class ang vehicle, maturn, sa tawag ka na. Basta kayo, mabali yung vehicle, no? Gusto kayong dagan niya, buliko ang galit. It's not good to if you're running in 150 km per hour and then suddenly you turn to the right or turn to the left, muna may tabo nga maligid ang imong vehicle. Why? Because of the fact nga ni-change ka of acceleration. So, there should be speed limit for every curve, no? Safe speed limit for every curve. That's why you can see a lot of speed limits, no? On the curve, no? For this particular load, mauni siya, no? Even if you observe some car in the velodrome, ito mga usog kayo ng mga mudagan ng mga car at sila sa halos na vertical, halos dako na kayo ang angle sa dalan, no? Nang grabe na kay kabakilid. So, in fact, kita ako salida sa circus nga, pwede ang motor mo dagan sa wall, no? Basta kuan lang, kusog lang yung dagan, pwede siyang mo dagan sa vertical wall, sa kusog lang yung dagan. Pero how about muhinay siya? Mahulog siya. Okay, mahulog. Okay, it has something to do with the the acceleration and also because of the mass of the motor. So times normal acceleration, walang pilit din siya sa wall because it's the coefficient of friction between the tire and the wall that controls nga dili siya mahulog. Okay. So anyway, we have a problem here. So we have a bird's eye view of a car traveling in this direction and entering into a curved path. Now, as the car enters, it reduces its speed to 72 kilometers per hour. Okay. Knowing that after 8 seconds, so the moment he enters the the car enters, no, the car enters into a uh, curved road. It says here, no, in the problem that he suddenly applies the brakes. So, wala gid ingon nga giduot niya, ginaya lang. There are many ways of applying brake, no. Pwede nga iduot nimo, pwede sa dog. Imo lang mo tanang friction para mo slow down. The term slow down is that wala gid niya gi-pull pag apply ang brake. So, after 8 seconds, so you know what is 8 seconds, no? So the interval 8 seconds, the car has been reduced to 72 kilometers per hour. Now, the problem is determine the acceleration of the automobile immediately after the brakes have been applied. Okay? So, na. So, solution. So, define your coordinates. No? Define your coordinates. So, then calculate the tangential velocity and the tangential acceleration. Then calculate the normal acceleration. Okay? So, isang dili na ta, mukha, no? Ato lang doing, no? So, solution. Okay, so, let us say ingon na mauni siya ang dagan sa kuan sa tao ba na ko pagkuhan ng curve, ha? Hindi lang siguro ko sa kuan ng lisod ang pag-doing actually. Sige lang. I will try. So, insert ko curve. Settings first curve. Okay. So, I have a curve here. Okay. So, mao na siyang curve. Pwede man kay curve. Ako to. Insert shape. Ay, ito sa curve. Okay, siya mas mahina ng curve. Okay. Then, let us say na siya arrow. Insert shape. Okay lang. Si arrow, ato lang yung mula yung color. Okay. So, muna siya. Ito lang kopyahon. Yes. So, mauna siya ang itawag na normal and tangential acceleration. So, muna siya ang paano. So, ang normal acceleration ani is mauna tangential acceleration. Okay? I'll put a subscript to that. Kanya, itong ganito ko, mauna siya ang normal acceleration. Okay? Normal acceleration. Okay? But actually, we are just looking this one, no? We are just looking this one. The resultant, actually, we are looking for the resultant. And that resultant is A. Okay, A. Okay. first we convert velocity from pph to MPS, meter per second. Okay. So if we convert sa tingalan ang 90 mph, ang conversion niya na is we multiply 1,000 to 90, that becomes meters, and divide by how many seconds in 1 hour, no? So 90,000 divided by 3,600, so we have 25 meters per sec. Diba? How about the 72? This is actually considered natin siya as the initial velocity, B1. Okay, B1. So as it enters the curve road. Okay. Then the next is ato nang kopyahon para ma-convert nato ang isa ka velocity, no? So this one is tawag na dito. Now this is after 8 seconds, tingin mo na siyang 72. So we have 72,000 divided by 2,600 equals 72,123 divided by 2,600. 72,123. 20. Nahimo siyang 20 per second. So muna yung epekto sa pag-break niya. Okay? So, we know nga ang tangential acceleration is equal to pt is equal kabalutan nga ang tangential acceleration pt is equal to dv dt, or that is equals to d sub 2 minus d sub 2 minus d sub 1 divided by 8 seconds. So this is the subscript divided by 8. So we have 5 divided by 8. 5 divided by 8 is equals to 0.625. 625, and the unit is meter per second squared. Okay, meter per second squared.
Sir, negative pa man na, sir ba?
Yes, negative na siya. Negative. Right, you are negative. Correct ka, no? So, buta na ito negative. Kalimot ko. Okay? Negative na siya. So, muna siya ang tangential acceleration. E sub t. Imo tayo subscript. Now, normal acceleration is the one responsible for making the car whirl. An is equal to b squared over r or rho. Okay. But which b we are going to use? Okay. So, determine the acceleration of the automobile immediately after the brake. So immediately after the brake, so at time 0, no? So at time 0, the V there is still 90 kilometer per hour or 25 meter per second pa, no? Okay. Pag tunog pa man sa brake ang giingon, dili man nga determine the acceleration after 8 seconds. Immediately after the brakes man ang giingon sa problem. Okay? Okay. Nahimo siyang 20 meter per second is after 8 seconds naman siya. So, you use 25. So, you will have an En equal to 25 squared divided by 750. So, you have this one as squared. Okay. And this one is a subscript. Okay. So that is equal to 25 times 25 divided by 750. You have 0.833 meter per 6 squared. Okay, 6 squared. Okay, kung if the problem is actually just to determine the normal tangential component, we already answered, no? Because you have now the tangential acceleration here, you have also the normal acceleration. But the problem is determine overall acceleration magnitude after the brakes and normal acceleration, no? So actually we will focus to this, no? Determine the acceleration but immediately after the brakes have been applied. So immediately after at time 0, okay, t is equal to 0. See, immediately after immediately after brakes are applied, you still have time equals to 0. That's the start of the deceleration. Time is equal to 0. Okay. Dahil sa itong istorya nga, after 8 seconds, so immediately after the brakes, the acceleration is if we have 80, okay, acceleration here is just equal to how are you going to solve for the acceleration here? You use SRSS, no? Using SRSS, you have an acceleration. You have an acceleration of equal to let us say squared is equal to 80 squared plus Tn squared. So mo na siya, no? Acceleration is 1. Okay, so SRSS is the square root of sum of square, no? This one is okay. So we have actually A equal to meter per second squared. So okay, i-square na ko na siya plus negative. This is negative, but if you square the negative 0.625, the same, no? Negative will become positive. So you have 1.04166 7 meter per second squared. So mauna siya ang answer. Actually, 1.041 7 squared. That is immediately after the brakes are applied. But that's the problem here. But okay, the other one is determine the overall acceleration magnitude after the brakes have been applied. Well, that is the case after the brakes have been applied. The same, the only the AN changes, no? Only the AN changes. It becomes 20 squared divided by 750. So ENA. We use the 20 meter per second velocity, not the 25, because it says man after the brakes. Yeah. We don't have. This is just another condition actually. The normal acceleration after 8 seconds is you have 400 divided by 750. 0.533 meter per second squared. Okay. So only this one is I think required. This one, only that one. Okay, because we only answer what is in the problem. Okay, determine the acceleration of the automobile immediately after the brakes have been applied. So this is a very practical problem. No, it does not involve it does not involve gravity. Why? Because gravity is not involved here. No, na, there's no such thing as pulling body here because the automobile is prevented from falling because of the road. So there must be an acceleration that cause the automobile to curve, no? Curve. So in our solution, we determine the tangential acceleration and normal acceleration, but luckily we have already derived the En and Et. No? So we know that Et is the change of speed. Now there's a change of speed here and given time, so we can solve Et. And then En is b squared over rho. We solved that already, but which speed? But another statement of the problem is that immediately after the brakes have been applied. So you use the 90, not the 72, or the 25 meter to 20. Now, this is tricky because the given speed is 90 and 72. If you are going to use that directly, you notice that the linear measurement here is kilometer and the time measurement is hour. So you need to be consistent with your unit. If you use meter, all will be meters and all will be second. No, there will be no uh, there will be no 2 units of time in a calculation. So as much as possible to make your solution a lot simpler, use only one time unit and one distance unit. Okay, you have to decide that. Okay, save that. Okay, class, nakuha ninyo ang problem. We have question. Saan ito? Kung nababay namin sunod. Okay. So, that is example 1. Okay, I am going to discuss example 2. Then I am going to give you your assignment. Okay. And the assignment actually, class, is just the same as our solve our problem that we solved this morning. But I'll just change the data. No? So, just to for practice purposes. No? Okay, let's go to second problem. Okay, this is example 2. Okay, so we'll have a solution to this. Solution. Okay, so this is different, no? So ma-share ka ng siguro class nakasakay ban mo ka ng mga Ferris wheel, no? Huwag ka ng Ferris wheel, hinaya kayo ang imong ma-experience na. And then the you are traveling in a perfect circle, no? So there is no change actually, no? Of the normal acceleration because no, the row there, the row, if the angular velocity is uniform, and then the radius is the same, so meaning you're traveling in a perfect circle, yeah, such as this, no? This is what they call like a centrifuge cab, no? So maybe this is uh, an equipment, no, for training pilots, no, or maybe kanang mga cosmonauts, no? So ilan yung subject ani, no? But there are, you can also find some mga rides, no, sa mga amusement park na grabe kayo ang G ni mo nga ma-experience. So G as in gravitational force, no? Gravitational force. I understand that some pilots actually nagkikining ga ga pilot sa mga jet fighter, no? So maka-experience na sila of more than 2G, 3G, 4G, no? So but their body actually is being trained, no? So maybe this one is a trainer, no? Okay. So anyway, this is just a tangential centrifuge cab. Okay, so the way centrifuges are working is like this. That's why it's called centrifuge cab. So the tangential acceleration of a centrifuge cab is given by this, no, acceleration. Okay, where t is in seconds and et is in meter per second. So there's no problem with units. If the centrifuge starts from rest, determine the total acceleration magnitude from test. What is wala na ako sa definition na rin. Test, no, test. What is test? Test. Ako sa tanaw ng definition sa test. Saan siya? Naya ko. So, actually, ang ikaw sa naku ang kuwan. Okay. So, mo ni siya ang second problem na to, class, no? So, doon na kay centrifuge cab, no? Okay? The tangential acceleration of this cab is a function of time. So, meaning, yeah, it varies with time. So, in fact, here is 0.5 t meter per second squared. Okay, t is in seconds and acceleration is meter per second squared. So, the given is tangential acceleration. If the centrifuge starts from rest, determine the total acceleration. Okay. Okay. So that's why I'm going to determine the meaning of tawag yan. Meaning sa rest. Okay. So ako sa wala ko sa meaning word niya rest. Okay. Okay, ingon man nga event, no? Event ang meaning. So, event ang meaning. So, we will solve this, no? So, define your coordinate system. So, bali, hindi lang yapon, siya circle, no? Circle. Circle na siya, circular. I will insert here circle. Okay. So, it's like that. Then, 1, 2, 1. Okay. So, muna siya yung path. The since ka, as you look at it on the bird's eye view, then butangan na to. Wala na. Okay, kasi nga, muna siya. Muna siya ang yung normal component. Okay. Normal component. And then we will copy that. Copy and paste again. Muna siya yung initial component. Okay. So, ayay. Okay. So, mauna siya ang atong tawag na acceleration tangential and the second one is acceleration normal. Okay. I will put that as a whole script. This one also ito na siya. Okay, so muna siya. Okay, so that is our figure. No? We have a circle here. Simply because, why a circle? Because this is a centrifuge cab with fixed radius, no? So it travels circular about the pivot point here, no? Located near the fulcrum. Fulcrum may tawagan na. Okay. Okay, so we know also that acceleration is equals to dv dt. Okay, we know this, no? Acceleration. So from that, we can have an equation dv equals to a dt. Okay, but in this problem, acceleration is a function of time. So we can actually calculate that is equals to 0.5 t dt. Okay, so we can have velocity actually if we integrate, no? If we integrating about equation. So may labas ito na tayo. V equals to 0.25 t squared plus c. Okay, ito ba? Plus?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So, we'll solve the constant of integration. So, you see at time at t is equal to 0, v is equals to do. And usually, that's equal to 0. 0. Okay, kay kuan man. Pag sugod pa man, pag sakay niya sa tao, ay pare sugod ang acceleration. So, 0. Okay. So, 0 meter per second. So, our equation for B is equal to just 0.25 t squared. Now, I think this is the tangential velocity. Or just B. Okay. So, calculate the normal after 10 seconds. So after 10 seconds, because there is an acceleration after 10 seconds, or t is equals to 10, say, you can have an acceleration. Acceleration is equal to 0.5 times 10. This is equals to 5 meter per second. So, in fact, this is what we call tangential. Okay. After 10 seconds, muna siya ang kuan. But we can have also velocity, tangential velocity after 10 seconds, which is 0.25 times 10 squared. Okay? Times 2 ha. So, ito lang kaon ng So, 100 times, this is na. Ini siya may tinuod nga meter per second. Now, it says here, determine the total acceleration magnitude of the cab after 10 seconds. So, we have already tangential, normal na lang. So, En is equal to B squared over R. Okay? This one is A. This one is subscript. This one is superscript. So we have 25 squared divided by 8. So what happened is that 25 divided by 8. 25 times 25 divided by 8. We get 78.125 meter per second squared. This is one day. Okay. So with the En, with this value and this value, we can calculate. No, exactly. We can calculate the A actually, using SRSS. Okay, SRSS is the square root of the sum of squares. So you will have acceleration. Acceleration is equal to square root. Ako na lang yan yung square root ha kay kanang raised to the power of 0.5 mag-isod ko kuan sa square root, buhat ang square root, raised to the power na lang. Doon na niya gitawag og 2t squared plus En squared. Ini siya is subscript. Ini siya is superscript. Ini siya is subscript. Is superscript. Una na din ko equal to meter per second squared. Ito na lang to. 78.125 25 25 divided by 8 ito good squared plus 25 78 wow 78.28 ito so unsa ko kani siya. So acceleration is equal to pila kani siya ka G. star niya. Okay. Divide na kung 9.81, divided by 9.81. Almost 8G. So, 7.98 G. Okay. So, you have a 7.98 G acceleration, no? So, or 70.284 meter per second. So, di pa mabuhi pa mong tao, ano yung sakay? What's the limit of, what is the threshold of human endurance with respect to G? So, if G is very very strong already, no? G. 1G is, mapilit na ka na sa wall ka ng 1G. 1G nga, mapilit na ka na sa wall. So, kung garutit ang bahala pa na siya sa loob, di ka mahulog kaya nipilit ka sa wall. So, if you experience G, kanang G, kanita na ka sa 50th floor, no? Elevator. Experience G, 1G, unsa nang 1G nga acceleration, is kanang feeling of weightlessness ba? So, like for example, na ka sa elevator, ninaog ang elevator similar to gravitational pull, no? So, like for example, nag-accelerate siya o i-simulate niya nga wala siyang nahulog bro kasi wala siya naputol so naputol ko na kabli, no? So you will experience weightlessness kaya naman parehaman mo nahulog ang elevator cab nahulog ikaw sa nahulog so medyo kung nauna ka ni kahulog ang elevator ay ka magtawan ka to madungan mo yun ka, no? Yan na. So you will experience weightlessness that, no? Yeah, kanang maka-experience ka G, kanang magsakay bitaw ka ng mga roller coaster, you will experience G there, no? A lot of G. So this 7.20 G is very big already, no? So I am asking if human can still withstand this kind of acceleration. Grabe naman kaya niya siya. So, like that. So this is the problem all about, no? Okay? You have a centrifuge cab. After 10 seconds, grabe kayo po. Sometimes, kung diligin makaagwanta ang structural component, ang mahita mo bitaw, ini atong cab niya mulupad, no? Mulupad siya kay grabe naman kayo ang force. Mabugto kung ginakadugayan, no? Padayon din siya. Tanta, ibutan niya 1 hour niya. Mauni siya, dili musta kaya acceleration. Grabe na kayo ni siya nga kakusog, no? Grabe na kayo kakusog yung dagat, no? So, yung manana. So this is that's the so I have akong nabuhat class is I have so I have practically derived the tangential abnormal acceleration component this morning and then solved 2 problems about tangential abnormal component, no? So in that case, doon na ay force nga makapa-cause of curve sa particle other than the gravity, no? Especially that the gravity is not involved. Okay? Just like our planet, why it is revolving around elliptical manner, no? So doon na siya kanang gravitational pull, no? Kasi pull kanang which is equals to the velocity squared and the r, no? So that is also mo na siya ang mga force nga makapa-form. Okay. Do you have question? Do you have question, class? Hello.
None, sir.
None. So I have already given an example. So as I have told you, I am not going to use all the 3 hours now. So I might stop at this point and then pabuta lang ninyo ako nang i-download niya, ako nang i-upload as your assignment. Okay? So, ano lang. Okay? So, ano lang, pabuta lang ninyo nga ma-upload na ko ang kuha na ang inyong assignment, ha? Assignment. Ang assignment is pareha na to, but you still have to submit it, no? I will put a page where you submit, where the assignment is, and also the deadline. The deadline will we meet only once a week, so I'm going to put that next week, no? So, I might set the deadline on Friday evening, okay? So you have too much time actually, and then it's not really very difficult because we have already. Actually, it's just an exercise, no? Okay, I have maybe some of you are not yet here. So today, last week, dito siya tawag na midterm, no? So medyo na kuan-kuan to kay ano na kung midterm late na. And then so that's why I give you the take home, no? But I realize na dili ang dito midterm. Actually, it's just an exam week. Actually, dalawang nila o prelim, no? Prelim. Okay. Okay, class. So, see you next meeting. Okay?
Thank you, sir.
Sir,
Yes, sir.
Okay, so just wait for the assignment to be uploaded. No?
sir Nadek.
I might yes, Mr. Ilan.
Sir, i-upload to nimo ang kwan, sir. Ang gibuhat nimo karon.
Oh, i-upload na ko na siya, pero natin sa sarili nga karon gyud kasi after lunch nga na. Basta i-upload ko to siya.
Thank you, sir.
Okay, sige. Okay, so I'll send out. Bye-bye.